We are going to be doing some problems here on page 578. We're going to start with number 17 here. And they're going to ask us find the area of the shaded segment. This is called a segment here. Just kind of like this little sliver up here. This one here is going to require a couple of steps here. One, you're going to figure out the area of the entire sector. So as if everything was shaded. So this is called a sector. And so you're going to figure out whatever this area is. You're going to minus out the triangle. So if I just minus out this portion of it, then you're left with what is called the segment part, which is this top shaded part, which is what we're trying to figure out here. The area of the sector hopefully is not a big deal. You take the angle degree, the arc degree, 120, put that over 360, and since you're dealing with area, you multiply it by pi r squared, pi 6 squared. The triangle is going to be a different beast, however. By the way, if I multiply this out, this is 12 pi, or 37.70. Now the triangle is not your traditional right triangle. You have 120 degrees arc, you have 120 degrees central angle. This is 6 centimeters. This is also 6 centimeters because it's the radius. You are going to have to use the formula for when you have a side, an angle, and a side. Instead of your traditional base times height, the area of this triangle is going to be 1/2 b times c, which are just side lengths, times sine of a. So the area of this triangle is 1/2 6 times 6 times sine of angle A here is 120 degrees. Throw that into your calculator. The area of this triangle, I cheated and figured this out already. This is 15.58. So that's the area of the triangle. And then you just minus these two pieces and you get 21.12, and this is centimeters squared. That would be your remaining part. So figure out the area of the entire sector as if everything was shaded, and then minus out the area of the triangle, and then you're left with the top part. Okay, this is number 23 here. We're going to figure out the area of this shaded portion here again. I'm going to approach this two ways. I'm going to figure out the area of the big sector, which is all of this, and then I'm going to add that with the area of the triangle portion. So that's this triangle right here. And so I'm going to have to figure out the area of a sector and then the area of the triangle, and together you get the entire area. The sector, well, we got to know this degree. If it's 120 degrees here, then 360 minus 120, this would be 240 degrees there. The area is 240 over 360, then multiply that by the pi r squared, the area of a circle, pi r squared. Multiplying all of this out, you will get 54 pi, or you can 54 times 3.14, the pi symbol is 169.65. Now I'm going to figure out the area of this triangle. Now this, again, this is not a base times height type triangle. This is a 1/2 9 or side length times 9, the side length times sine of 120. Throw that into the calculator, you will get 35.07. If I add the sector with the triangle, you get a grand total of 204.72 centimeters squared. 23. Okay, this is number 25. Find the area of the shaded region. You're not going to try to figure out the area of one of these bizarre looking corner pieces here. The way you're going to figure this thing out is figure out the area of the entire square as if everything is shaded, and then you're going to minus out the circle. And if you minus out the circle, which is obviously in the square, if I minus it out, then you would get just the shaded corner pieces. So the key here is we're going to figure out the area of the entire square and then minus out the circle in the middle, and then you're left with just the four corners there. So this is a 2 by 2, so that's simply the area of the square is 2 times 2, which of course is 4. And then this has a radius of, from here to here, if it's 2 all the way across, this is a radius 1, pi 1 squared, pi r squared. And that is 3.14. 4 minus 3.14 is 0.86-ish. I'm rounding that. And this is feet squared. And that is the area of the four corners. The four corners once you subtract out the circle part. And that is number 25. Okay, 27 is an unusual looking picture here. You have to figure out the area of the shaded region. It kind of looks like, I don't know, a star here. There's no real formula for area of a star. So you're going to have to kind of break this into, what am I really looking at here? If I take this piece here, A, and I'll put a B here, and a C here, and a D here, and if I combine those pieces that are unshaded, you will actually get a circle. And this part here, where it's curved down here at the bottom, would be A. This curvature would be part B. This curvature would be C. And this one is D. But if I add them all together, it makes a circle. So what I really want to do here is just figure out the area of an entire square, which, by the way, this is 14, 14. 14 plus 14 is 28, 28. And I'll minus out the area of the circle. Now the circle again is broken into 4 parts, and from here to here is 14, just like this. And then you're going to be left with the star shaded part, because you basically subtracted out this, 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 and this, and you're left with just the middle part. If you shade out the rest of these corner pieces, you're left with the middle. Okay, so the area of a square is simply 28 times 28. That is 784. This is pi r squared, 14 squared. 14 times 14 is 196 pi. 784 minus 196 times pi is 615.75. And then, oops, not on the screen. And then this would be 168.24 inches squared. Okay. Again, what you're looking at is these 4 corner pieces make an entire square. You minus it from the square, you're left with just the star shaded part in the middle. 27. Okay, I'm going to do number 29 here. I'm going to first read it. Writing. The American Institute of Baking suggests a technique for cutting and serving a tiered cake. The tiers of the cake have the same height, so up and down is the same, and have a radius of 8 inches, and then the bottom one is 13 inches. The top tier and cake directly under it are cut into 8 wedges as shown. So this top one is cut into 8 wedges. The outer ring of the 13-inch tier is cut into 12 pieces. Which would be larger, a piece from the top or a piece from the outer rim? So basically, what would be a larger area? This piece on top, or now this bottom one here is cut into 12 pieces, or this piece here on the bottom. And I'll put this in pink here. This piece here in pink. All right, so we got to figure out the area. Because they have the same height, we don't have to worry about the up and down part, because they are going to have that same height thickness. So we're going to figure out the area of this guy. Now this has a radius of 8, and this one here on the bottom, it would go all the way to 13. It's hard to draw a 13 on this radius here. So I'm going to just put this in the two-dimensional world now. For the top cake, I want to do a comparison here. This is just basically a circle split into 8 ways. Radius is of 8, so I'm going to go pi 8 squared, which of course is 64 pi, and then divide that by 8, because there's 8 pieces. So each piece is 8 pi. That's inches. You know, that measurement doesn't even matter. But essentially this is 8 pi here, and that's for the top layer, this guy right there. One of those pieces is 8 pi. Now you can multiply that pi symbol out, but I'm just going to keep everything in pi. Now I'm going to compare that with the bottom tier, this pink cut here. Now what you got to remember with the pink cut is, okay, you got this bigger circle, which is 13 inches, but then you're also got this top layer on top of it, which is 8 inches. And all you're going to do is deal with this bottom part of the tier. This is the bird's eye view. And then this shaded part gets cut into 12 pieces. But first, let's just take the big circle, which is 13 pi, minus out the top tier, the 8 pi, 13 pi, 8 pi. We're going to minus out the top layer, and that will give me the shaded part, and that will give you the shaded region around the cake. Okay, 13 times 13 is 169 pi. That's 64 pi. That's the top portion. 169 minus 64 is 105 pi. That is the entire shaded part, as if everything here was pink. Okay, we're trying to figure out everything up on there. Then we're going to divide it by 12, because we're going to cut this into 12 pieces here, the cake. So divide it by 12. 105 divided by 12 is 8.75 pi. And that's the pink part. So what is going to be the bigger slice of the pie? It's going to be the pink piece on the bottom, excuse me. So it's the outer rim is going to have a bigger piece of the cake.